Okay, here we go. Let's do some 2D relative velocity. Let's start off with our question. We have a large panel car has a velocity of 30 meters per second at 20 degrees south of east in still air. A gust of wind of 20 meters per second due east relative to the earth strikes the van. What is the resultant velocity of the van relative to the earth during the gust? Okay, so let's label things. So we've got velocity of the car relative to the air, so car relative to air. We've got a gust of wind relative to the earth, so it's velocity of air or wind, that's fine, relative to the earth, but you need to be consistent, so we're going to call it air. And what is the resultant velocity of the van relative to the earth, right? So let's set up our little equation. We want the velocity of the car relative to the earth. And we need to make our little sandwich. So what we need is the velocity of the car relative to something plus the velocity of the something relative to the earth. See, we need our little sandwich. Okay, what's our consistent? We've got air. So we fill up our sandwich by putting A and air and air. So we've now got the velocity of the car relative to the earth is equal to the velocity of the car relative to the air plus the velocity of the air relative to the earth. Do we actually have all these values? Yes, we do, in a perfectly normal, straightforward fashion. Great. Let's just do a little compass so that we don't get ourselves completely lost. Okay, here's north, west, east, and south. So let's start off. Let's start off with the easy one. We've got the velocity of air relative to the earth. It says due east. That means exactly straight east. Okay, then we've got so that is the velocity of the air relative to the earth. What's its value? 20 meters per second. Okay, next one, velocity of the car relative to the air, which is 20 degrees south of east. So it's kind of like here. Okay, so let's put it in, and we're adding them, so they must be head to tail. Okay, this is about 20 degrees. Great, and this is our resultant velocity. This is what we are looking for. Perfect. So what do we have? We've got this angle here. Oh, we also have this. This is given, it's up here, and this is the velocity of the car relative to the air. Remember to label everything. That's about 20. This is meant to be 20 degrees. This is 20 degrees south of east. So this angle here must be 160. Perfect. Okay, what can we use? We can use our cosine rule. Yay, nice simple one. A squared equals B squared plus C squared minus 2BC cos A. Okay, so that is, that would mean, remember I said label everything. This is why we get confused. Velocity of the car relative to the earth, question mark. So we've got velocity of car relative to the earth is equal to the square root of B, 20 squared, plus C, 30 squared, minus 2B, 20, C, 30, cos A. Okay, just equal to, that's just straightforward. Put it on your calculator as is. And what do we get? We get 49. Now, I am going to put down, I'll show you a trick that I always do. What I always do is I write down several significant figures in case I need the number later, right? That's the number on my calculator, if you can see, I don't know. And I've written down several significant figures, and I will do this, and I'll say that's around about 49, because we only have two significant figures in the problem. 49 meters per second. Remember, physics, units. Great. Now, what else do we need? Is velocity just magnitude? No, it has a direction. Where is our direction? In this case, it is this here. Shall we call that alpha? We're going to call that alpha. So we need angle alpha. So simple, straightforward sine rule. We've got sine alpha is equal to, let's go with this one, 160, sine 160 over this, which I've said is 49.271. Try and keep significant figures when you're doing your calculations. You can even keep the number in your calculator. This is fine as your answer, but it's useful to just hang on to significant figures when you're doing more calculations. Times by, here we go, 30. What do we get? Again, straightforward calculator time. Sine 160 over 49.271 times by 30. What do we get? Oh, we forgot to put the, well, that is the answer for sine, but what do we actually want? We actually want alpha. So I need to do the shift sign program. Sorry, you can't even see. There we go. Okay, what do we get? 12.01, that's fine. So we can say that alpha is equal to 12 degrees. 12 degrees what? 12 degrees south of east. Now, of course, it would depend on what the question was asking. If they just said direction, this is fine. If they say bearing, that's a different story. So there you go. If you want to write it as a single answer, you can always do this. Velocity of car relative to Earth is equal to 49 meters per second, 12 degrees south of east. And you're done.